This is going to be the solution to number 11 and number 11 only, so solving a system of 3 variables. Looking at this problem, looking at the x's, 7, 3, and 5, y is 5, negative 5, 3, and z's, I think that y will be easier to eliminate, mostly because I already have a positive 5y and a negative 5y in there. So I'm going to choose to eliminate y, write myself a little note so I don't forget. So because there's that positive 5y and negative 5y, I'm going to pick the first 2 equations first. So let's rewrite those, and then we can just add them right away. We already have a positive 5y and a negative 5y, so we're going to add them up. We end up with 10x minus z is equal to positive 8. Put a box around it because that's one of our 2 that we need for the third round of elimination. My next 2 that I pick are going to be the second and third, only because either way I'm going to have to get 15, but I already have a negative and a positive, so I don't have to worry about changing the sign of anything. So I'm going to recopy those as is, and then I need negative 15 and positive 15, so I'm going to multiply that first equation by 3 and the second equation by 5. I already have opposite signs, so I'll go ahead and distribute the 3 to the first equation, distribute the 5 to the second equation. Now I can go ahead and add them up because I have a negative 15 and a positive 15y. So I put a box around that equation, and I know the numbers aren't very pretty. So what I'm going to do is I think it's going to be easier, and I'm only going to have to change one equation if I eliminate the z's. So I'm going to multiply that top equation by negative 29 because I already have a negative 29z, so that means I want a positive 29z. So I'm going to go ahead and distribute that negative 29 to the first equation, and then it's ready to add because I have a negative 29 and positive 29. When I add, the numbers are big, but they end up working out quite nicely so that I get x is equal to positive 1. I now need to plug this back into one of the 2 boxed equations. I'm going to pick the first one because the numbers are smaller, and plug in 1 for x and solve. We end up getting z is equal to positive 2. So once we have 2 of our 3, we need to plug in both of them into one of the original equations. So I picked the third one. I plugged in 1 for x and 2 for z, and all we have to do is solve for y. We get 3. The very last part of this problem is to write it in an ordered triple format. So make sure we go x, y, then z. So 1, 3, then 2. And that's it.